In this example, we will enter all the settings needed to configure our D60's 4 zones of protection. These parameters can be entered into the settings file using the InterVista UR setup program. All the steps necessary for creating a settings file can be found on the UR Applications 1 CD. A settings file has already been created for use in our example. For this example, the model number D60 A00 HCH F8A H6P M6P with firmware version 3.3 will be used. This relay has the A-type CPU. It is the horizontal 19-inch rack style, has the standard 4CT and 4VT analog inputs module in slot F, and two 6P digital input-output modules in slots H and M. Detailed descriptions of these modules can be found on the UR Applications 1 CD. The first steps after creating the settings file are to do some of the basic setup functions. Enter the CT and PT ratios and system parameters as follows. Go to the newly created settings file in URPC, Product Setup and Installation. Change the setting Relay Settings to Programmed. Provide the relay with a name if the default name is not sufficient. For this example, we'll use Example Relay. Then save these settings to the settings file. Enter the CT and VT ratios as follows. Go to System Setup, AC Inputs and Current. Enter the phase CT primary as 1200 amps. The phase CT secondary is already the required 1 amp. Since this is a single line and not parallel line example, no ground CT will be used. Thus, the ground CT primary and secondary are not to be used. Then save these changes to the file. Go to System Setup, AC Inputs and Voltage. Enter the phase VT connection as Y, the phase VT secondary as 66.4 volts, and phase VT ratio as 1200 to 1. The auxiliary VT will not be used, so disregard its settings. Then save these changes to the file. We will now enter the power system parameters as follows. Go to System Setup and Power System. Change the nominal power system frequency to match our power system of 50 Hz. Set the phase rotation to be ABC. Set the frequency and phase reference as Source 1 and enable the frequency tracking function. Now save these settings to the file and close the window. Next, we will enter the signal source settings so the relay can meter properly. Go to the System Setup, Signal Sources menu. Assign F to the phase CT inputs of Source 1. The ground CT will not be used in this example, therefore the settings do not need to be assigned. Assign F5 to the phase VT inputs. The auxiliary VT again will not be used in this example and therefore needs no assignment. Save these settings and close the window. Next, we will enter all of the line parameters needed by the D60 as follows. Go to the System Setup Line menu. Enter the positive sequence impedance magnitude as 38.7 ohms as previously calculated. Enter the positive sequence impedance angle as 79.6 degrees. URPC will round this number to 79 degrees. Now enter the zero sequence magnitude as 98.2 ohms. Enter the zero impedance angle as 78.38 degrees, which URPC will round to 78 degrees. Enter the line length unit as kilometers. Now enter the line length as 100, representing 100 kilometers. Then save these settings to the file and close the menu. We will now perform all the calculations needed to set up our distance element zones of protection. All the distance elements that we are using will be the MO-shape characteristic. For now, we will only focus on the distance element settings. Distance protection schemes will be covered later in the course. Therefore, all of these distance settings will be based on a basic stepped distance scheme. For reference, the secondary impedances that we calculated earlier are shown here. As usual, the first three zones of protection will be set to protect in the forward-reaching direction. Zone 1's reach is normally set to be a maximum of 80% of the positive sequence impedance of the line. This is to avoid possible overreaching into the neighboring line. Therefore, Zone 1 will be equal to 0.8 multiplied by the secondary positive sequence impedance, which gives 30.96 ohms at an angle of 78.66 degrees. The Zone 1 characteristic is usually set to trip instantaneously, and thus will be set with no intentional delay. The Zone 2 reach is normally set to at least 120% of the positive sequence impedance of the line, or in many applications, to the positive sequence impedance of the protected line plus 50% of the shortest adjacent line. For this example, we'll take Zone 2 as 120% of the positive sequence impedance, which gives us 46.44 ohms at an angle of 78.66 degrees. The time delay for Zone 2 is typically between 250 milliseconds to 400 milliseconds. We'll use 300 milliseconds for this example. The Zone 3 reach is normally set to cover 120% of the next adjacent transmission line. For simplicity, we will assume the second transmission line's impedance is the same as the impedance of the line that we are protecting. Therefore, we will set the impedance of Zone 3 to be 240% of the impedance of our transmission, resulting in an impedance of 92.88 ohms at an angle of 78.66 degrees. Since Zone 3 is the backup to Zone 2 of the neighboring transmission line, it needs to have a long delay. A time of 1 second is typical. Zone 4 is normally set to provide backup for faults that occur just behind the relay in the reverse direction. The reach for Zone 4 is usually set between 20 to 50% of the positive sequence impedance of the line, but also depends on the impedance of the line on the adjacent transmission line that you are backing up. For this example, we'll set Zone 4's reach equal to 20% of the positive sequence impedance, which is 7.74 ohms at an angle of 78.66 degrees. The time delay for Zone 4 should be about the same as for Zone 3, since it is also backing up Zones 1 and 2 of relays reaching in the adjacent transmission line. A time delay of 1 second is typical. The very important value we need to calculate is the zero sequence impedance over positive sequence impedance ratio. This is necessary for the ground distance elements and needs to be calculated for each zone. For this example, we will assume that all lines have the same ratio, so the zero sequence impedance over the positive sequence impedance ratio will equal 2.55 ohms at an angle of -1 degree. We will now enter the calculated settings for the 4 zones of protection into our settings file as follows. Go to Grouped Elements, Group 1, Distance and Phase Distance. For each of the 4 zones of protection, set the function to Enabled. For phase distance zones 1 through 3, set the direction to Forward. For Zone 4, set the direction to Reverse. For phase distance zones 1 to 4, set the shape to Mow. We will now set the transformer voltage and current connection to 0 because there are no transformers in our zones of protection. Set Zone 1's reach to 30.96. And its reach characteristic angle to 78.66 degrees. Set Zone 2's reach to 46.44 ohms and its angle reach characteristic angle to 78.66 degrees. Set Zone 3's reach to 92.88 ohms and its reach characteristic angle to 78.66 degrees. Set Zone 4's reach to 7.74 ohms and its reach characteristic angle to 78.66 degrees. For this example, we want all of our Mow characteristics to be a complete circle. Therefore, for all zones, set the comparator limit angle to 90 degrees. Since we do not want to cut off any of our Mow characteristics, the directional reach characteristic angle will be set to the same angle as the reach characteristic angle, which is 79 degrees. For the same reason, the directional comparator limit will be set to 90 degrees for all zones. None of the quadrilateral blinder settings need to be set since we're using the Mow characteristic for all zones. The current supervision can be set to 0.2 units for all zones. The voltage level must be set to 0 for all zones since we're not dealing with a series compensated line. We will now set the individual delays for each zone of protection. The delay for Zone 1 is 0 seconds. For Zone 2 is 0.3 seconds. Zone 3 is 1 second. And Zone 4 is 1 second. We now need to set Zone 1 to Zone 4 to be blocked whenever the relay detects a Source 1 VT fuse failure. Set the target for each zone to latched and events to enabled to enhance troubleshooting. Then save these changes to the file. The zones we have just configured can be viewed on an RX diagram by clicking on the View button of any zone. In the window, you can see a diagram of the 4 zones of protection, each with the Mo characteristic shape. The first 3 zones, shown in red, green, and blue, are protecting in the forward direction. The 4th zone, in light blue, is protecting in the reverse direction. We will now enter all the settings necessary for the ground distance elements. Go to Grouped Elements, Group 1, Distance and Ground Distance. For ground distance zones 1 to 4, set the function to Enabled. For ground distance zones 1 to 3, set the direction to Forward. For Zone 4, set the direction to Reverse. For ground distance zones 1 to 4, set the shape to Mo. The zero sequence impedance over the positive sequence impedance ratio then needs to be entered for all zones as 2.55. The zero sequence impedance over the positive sequence impedance angle is -1 for all zones. Since this is a single and not paralleled line, both the zero sequence mutual impedance and the positive sequence impedance magnitude and angle must be set to 0 for all zones. Now set the shape and size of our 4 ground distance zones of protection. Set Zone 1's reach to 30.96 ohms. Set its angle reach characteristic angle to 78.66 degrees. Set Zone 2's reach to 46.44 ohms. Set its angle reach characteristic angle to 78.66 degrees. Set Zone 3's reach to 92.88 ohms. Set its angle reach characteristic angle to 78.66 degrees. Set Zone 4's reach to 7.74 ohms. Set its angle reach characteristic angle to 78.66 degrees. Since we want our mho characteristic for all zones to be a complete circle, set the comparator limit angle to 90 degrees for all zones. Since we do not want to cut off any of the mho characteristic, we will set the directional reach characteristic angle to 79 degrees, which is the same as our reach impedance angle. For the same reason, the directional comparator limit will be set to 90 degrees for all zones. None of the quad blinder settings need to be set since we're using the mho characteristic for all zones. The current supervision can be set to 0.2 per unit for all zones. The volt level must be set to 0 for all zones, since we're not dealing with a series compensated line. We will now set the individual delays for all 4 ground distance zones. The delay for Zone 1 is 0 seconds. For Zone 2, it is 0.3 seconds. For Zone 3, it is 1 second. And for Zone 4, it is 1 second. As in the phase distance elements, the ground distance elements need to be blocked whenever a VT fuse fail condition is detected. Therefore, set Zone 1 to Zone 4 to be blocked whenever a Source 1 VT fuse failure is detected. Set the target for each zone to Latched and events to Enabled to enhance troubleshooting. Then save these changes to the file. The zones can be viewed by clicking on View of any zone. Again, we will see 3 Mohs circles protecting in the forward direction and 1 in the reverse. This concludes our example of distance element settings.